10A. That starts on page 161. Number 1. In a certain class, midterm scores average out of 100 with an SD of 15, as do scores on the final. The correlation between midterm scores and final scores is about 0.5. What does that tell us? It's not a very good correlation, but there is a positive trend. So generally, if you do well on a midterm score, then you do well on a final score. But it's not a very good trend. It would be a really fat football. Estimate the average final score for the students whose midterm scores were a 75. So both the midterm and the final had an average of 60. So I have my X bar is 50 and my Y are 60. My Y bar is also 60 and they both have an SD of 15. So the SDX and the SDY are both 15. Okay? So I want to know if somebody scores 75 on the midterm, so this is final and this is midterm, what would we expect them, or what is our best possible guess of their score on the final? Now, if there was 100% correlation, you would go 15 to the right and 15 up. So this distance from here to here is 15, and that's 1 SD. So I should go up 15, but the correlation is not 100%. You multiply this by 0.5, and I get 7.5. Basically, I cut that in half, and I add that back to the original Y bar, 67.5. Okay? What about 30? 30 is 2 SDs below. So if I backtracked 2 SDs, that's a total of 30. I should go down a total of 30, but I'm going to do half of that and 15. And you'll notice this line right here is called, nope, that's the SD line. 1 SD right, 1 SD up. 2 SDs left, 2 SDs down. That would be the SD line. But the regression line is going to go through there. It finally clicked? Good. And our football, it's 0.5, so we're probably looking at something that looks like that. A huge variability, but there is a positive trend. Okay, nobody who aced the midterm is going to fail the final, right? There is a positive trend. All right, and 60. We would expect 60. It would be, so it would be 30 comma 45 because we go down half of 30. Yeah, 2 SDs left would be 30. 2 SDs down would be 30. But we only go half of that distance, so we go down 15. So the answer for B is 45. What about C? But wait a minute, don't we have to do half of the YSD? Half of 0 is 0, so 60 would be 60. Now, how accurate do you think that's going to be? If you measured somebody's midterm at 60, would you expect that their final would be exactly 60? No. It could be a little higher or a little lower. So we kind of have this much variability in our football. So we would expect it to be within 10 or 20 points of 60. And actually later on, we're going to create what we call a confidence interval. We say that the answer we expect is 60, but we know it's not going to be perfect. So instead of saying about 60, what we'll say is between 55 and 65, or between 50 and 70. And we can change the width of that confidence interval according to how confident we want to be. And that's where we're headed. Is these estimations are not perfect, but according to the shape of our football, we would expect it to be somewhere in there. Or if our football is narrower, then we would expect it to be somewhere in here. And that's called a confidence interval. We're pretty confident the answer is in that space. Okay, 2. Estimate the average weight of men whose heights were 69 inches. So we have the x bar is 69 with an SDX of 3, and the y bar is 190 with the SDY of 45, and R is 0.41, which is a pretty terrible regression. Oh. 40, oh, not the, okay, the SDY is 42. Okay, so estimate the average weight of a man who's 69 inches tall. So how many SDs is that? Plus 1. Oh no, sorry, 0. I looked at the wrong problem. So that's 0 SDs, so we would expect the Y value to be the average of 190. Okay, 66 inches. Down 1 SD, so we're going to take 190 and we're going to subtract 42, but it's not all of 42. It's 41% of 42. Yep, times 0.41. Maybe I should draw the picture. So here is our X bar comma Y bar, right? We're going to go left 1 SD, which means we go down 1 SD, but it's not a full SD. It's 41% of that SD, so we're going to cut it off right here. And the Y bar is 42. 41% of that ends up being 17.22, and we're going to subtract that from 190, 172.78. Okay, that's B. Now I really like C. This is a great question. C says, what if a man is 24 inches tall? Right, I subtracted it. Yeah. So what if a man is 2 feet tall? Well, how many SDs is that? 69 minus 24. That's 45 inches divided by 3. So we are 15 SDs to the left. Okay? So I have my point of averages, X bar, Y bar, and I'm going to go 15 SDs left, which means I need to go 15 SDs down, but not the full 15. 15 times 0.4. So 15 times 0.41 is 6.15 SDs. And how big is the SD for Y? 42 times 42. And then I'm going to take 190 and subtract the answer. And this man is negative 68 pounds. It doesn't work. Okay, so what does this tell us? This man does not exist. Right? He doesn't exist. According to our regression line, that would put him at negative 68 pounds. Now, could there really be an outlier that's 15 SDs away? No. If there was, then it would absolutely ruin the SD. Right? So if we had this football in there and we put a point right there, The SD would not be 42. The SD would be much larger. Does that make sense? So this person cannot have happened. You can't get more than 4 or 5 SDs away. Because when you do, the SD becomes longer and then it will capture all of the data within 4 or 5. Getting outside of 3 SDs is very rare. Remember, if we go back up to the picture, 3 SDs is 99.7. 4 SDs is 99.9999. 5 SDs is unheard of. 15 SDs just can't happen. It's way too far. Okay, so what about D? 0. That can't, we're not even gonna do it. Yeah, if you're 0 inches tall, you don't exist. So we're not even gonna bother calculating it. That cannot happen. So this is not a question about should we throw out the outlier or not. This is a question about can an outlier exist that far away? No, without ruining the SD. But the SD would be huge. 4 or 5 SDs, yeah. You can't really go beyond that. Yeah, yeah. If you want to read what they said in 2, it's pretty funny. Okay, 3. The men aged 45 to 75 had an average height of 69 inches equal to the overall average height. True or false, and explain. Their average weight should be around 190 pounds, that being the overall average weight. Okay, so what this is saying is I have a football, and the point of averages is 69 inches, comma, 190 pounds. Okay? That's the average of everybody. If I just took this group of men, would the average of those men be close to 190? What do you think? So this is height, and this is weight. So if we draw the SD line, 1, 2, 1, 2, and then 1, 2, 1, 2. So that's the SD line. The regression line is going to go through the middle of our football. Okay? And the SD line is always messed up a little bit because there are not as many people here as there are here. But if you look at the regression line, there are just as many people here as there are here. Right. The regression line is the half of every single height. The regression line will cut every column exactly in half. The SD line doesn't. Well, either direction. If you make a column, then the SD line or the regression line should run through the middle of that column. But if you create a row, then the regression line should run exactly in the middle of that row too. Okay? So, if I took all of these people and all of these people and averaged them, would we expect the answer to be close to the average? I would say yes. That's what the regression line does. It splits every column into 2 equal halves. The book says false. Uh-oh. Maybe I misunderstood the question. Uh-oh. See what happens when you start trusting me? So this is 10A. Okay, 10A. We're on question. Oh, okay. So the answer says, think of the scatter diagram for the heights and weights of all the men. Take a vertical strip over 69 inches representing all the men whose height was just about average. Their average weight should be just about the overall average. Isn't that what I said? But the men aged 45 to 74 are represented by a different collection of points. Oh, I didn't even take that into account. So this is not everybody. That's okay. So my explanation was true. This blue dot, that blue circle, and that blue circle are the same size, but this is qualified by age. So their average weight would be the same, but the men aged 45 to 75 are represented by a different collection of points, some of which are in the strip and many of which are not. The regression line says how average weight depends on height, not age. So I misread the question. Right. So we're not looking at one column. If we looked at one column, that would be true. We're looking at a group of men by age, which doesn't tell us anything about their height. So, yep, I misunderstood that question. Sorry. Number 4. For women aged 25 to 34 in the U.S. with full-time jobs, the relationship between education and personal income can be summarized as follows. X bar is 14 and equals 14, and SDX equals 2.4. Y bar is 190 with the SDY equaling, oh wait, where am I going? I'm on the wrong page. 32,000 with the SDY equaling 26,000, and R is 0.34. Are the Y values normally distributed? Look at the Y bar and the SDY. Are the Y values normally distributed? I know they're not. How do I know they're not? The SD, right. One SD almost gets us to 0, Bryn, right? So this cannot be normally distributed because one SD to the left almost gets us to 0. So this will be a right-tailed, which we already knew income was right-tailed, right? So one SD puts us pretty close to 0. All right, the question asks, estimate the average income of those women who have finished high school but have not gone on to college. So people with 12 years. It's not an SD. How much of an SD is it? So we take, what's the difference between the average and 12? 2 years. So 2 years divided by 2.4 tells us that from the point of averages, we're going to go left 0.833 SDs, right? 0.833 SDs, which means we need to go down 34% of 0.833 SDs. That's R, and then we multiply that by the SDY. 0.34 times the answer multiplied by $26,000. So we're going to drop $7,366. So I take 32,000 and I subtract the answer 24633. That would be the estimate. Now, how accurate do you think that's going to be? Hardly accurate at all. Why? R is 0.34. That's nearly a circle. Okay. Suppose R equals -1. Can you explain why a 1 SD increase in X is matched by a 1 SD decrease in Y? Well, it slopes down. How do we know it slopes down? So R is negative, so our slope is that way. Do we have a good football? It's actually a straight line. So all of the points are in a perfect line. Do we know how steep the line is? No, we have no idea. So the line could look anything like this, but it is a perfect line. So 1 SD right is equal to 1 SD down. Now those might be different. We might go right 5 and down 300, but it's still 1 SD and 1 SD. All right, that takes us to the end of A.